This situation involves a 225 kVA dry-type transformer with a 480 volts to 230 volts configuration, K-4 rated, serving primarily nonlinear loads. Testing has revealed a K-factor of 9 exceeding the transformer's K-4 rating, despite the transformer being only 50% loaded. Here's a structured approach to address this problem. Firstly, verify the test parameters. It is crucial to ensure that the test setup and measurement equipment used to determine the K-factor are accurate and properly calibrated. Repeat the test to validate the initial findings. Inaccurate measurements can lead to unnecessary interventions. Secondly, assess the load characteristics. Carefully examine the types of nonlinear loads connected to the transformer. Nonlinear loads, such as switch-mode power supplies and variable speed drives, are significant contributors to harmonic distortion, which directly impacts the K-factor. Understanding the specific harmonic profile of these loads is essential. Thirdly, consider installing harmonic filters. Harmonic filters are designed to mitigate harmonic distortion at the transformer's input. These filters help reduce the harmonic currents and voltages, thereby lowering the K-factor. The type and size of the filter must be carefully selected based on the harmonic profile of the load. Fourthly, explore the installation of K-factor correction capacitors. Capacitors can be used to offset the inductive reactance of the transformer and improve the power factor. However, the capacitance value needs to be carefully calculated to avoid resonance issues, which can amplify harmonic currents and create other problems. Fifthly, monitor the transformer temperature diligently. Under the existing load conditions, closely monitor the transformer's temperature. If the temperature exceeds the specified limits, immediate action is required to prevent damage to the transformer. Overheating can significantly reduce the lifespan and reliability of the transformer. Sixthly, reduce the transformer loading. Consider redistributing some of the nonlinear loads to other available circuits or transformers, if feasible. This will reduce the current flowing through the transformer, thereby lowering the K-factor and reducing the thermal stress on the transformer. Seventhly, evaluate the possibility of transformer replacement. If the previous measures do not provide a satisfactory solution, replacing the existing transformer with a unit rated for a higher K-factor might be necessary. A transformer with a higher K-factor rating is designed to withstand the additional heating effects of harmonic currents. Eighthly, consult with a transformer specialist. Seeking advice from a qualified transformer specialist is crucial. The specialist can assess the situation thoroughly and recommend the most appropriate course of action. They can provide guidance on proper transformer sizing and operation, especially under nonlinear load conditions. Additional considerations include the fact that the K-factor limit of 4 is generally specified for transformer ratings up to 500 kVA. For larger transformers, a higher K-factor limit might be acceptable, but this should be verified against relevant standards and guidelines. The actual K-factor of a transformer can vary with the load conditions and the type of nonlinear loads connected, making it essential to perform regular monitoring. Finally, balancing harmonic mitigation with the potential impact on power factor and system stability is important. Any corrective measures should be evaluated for their overall effect in the electrical system. In more detail, consider these aspects. Harmonic distortion is a significant issue in modern electrical systems, particularly those serving nonlinear loads. These loads draw current in a non-sinusoidal manner, creating harmonic currents that propagate throughout the electrical system. These harmonic currents can cause a variety of problems, including overheating of transformers, increased losses in conductors, and malfunctioning of sensitive equipment. The K-factor is a measure of a transformer's ability to withstand the heating effects of harmonic current. A transformer with a higher K-factor rating is designed to handle high levels of harmonic distortion without overheating. In this case, the transformer has a K-4 rating, meaning it is designed to handle a certain level of harmonic distortion. However, the measured K-factor of 9 indicates that the harmonic distortion exceeds the transformer's capacity. Verifying the test parameters is a critical first step. Ensure that the testing equipment is properly calibrated and that the test procedure is accurate. Common methods for measuring K-factor involve analyzing the harmonic content of the load current. The accuracy of the test equipment and the test procedure can significantly impact the results. Assessing the load characteristics involves identifying the specific nonlinear loads connected to the transformer. Common nonlinear loads include switch-mode power supplies, variable speed drives, electronic ballasts, and uninterruptible power supplies, also known as UPS. Each of these loads generates a different harmonic profile. Understanding the specific harmonic components is important for designing effective harmonic mitigation strategies. Installing harmonic filters is a common method for reducing harmonic distortion. Harmonic filters are designed to shunt specific harmonic currents away from the electrical system. There are two main types of harmonic filters: passive filters and active filters. Passive filters consist of inductors, capacitors, and resistors, and they are tuned to filter specific harmonic frequencies. Active filters use electronic components to actively inject harmonic currents that cancel out the harmonic currents generated by the nonlinear loads. Installing K-factor correction capacitors can improve the power factor and reduce the voltage drop. Capacitors supply reactive power to the system, which can offset the inductive reactance of the transformer and other equipment. However, it is important to select the appropriate capacitance value to avoid resonance issues. Resonance occurs when the capacitive reactance of the capacitors equals the inductive reactance of the system, which can amplify harmonic currents and cause voltage distortion. Monitoring transformer temperature is an essential part of maintaining transformer health. Overheating is a common cause of transformer failure. Monitoring the transformer temperature can provide early warning of potential problems. If the transformer temperature exceeds the specified limits, it may be necessary to reduce the load on the transformer or take other corrective actions. Reducing transformer loading can reduce the harmonic currents flowing through the transformer, which can lower the K-factor and reduce the thermal stress in the transformer. This can be achieved by transferring some of the nonlinear loads to other available circuits or transformers. Consider the possibility of transformer replacement if other measures are not effective. A transformer with a higher K-factor rating is designed to withstand the additional heating effects of harmonic currents. Replacing the existing transformer with a unit rated for a higher K-factor can provide a permanent solution to the problem. Consulting with a transformer specialist is crucial for ensuring that the transformer is properly sized and operated. A transformer specialist can assess the situation, recommend the most appropriate course of action, and provide guidance on proper transformer maintenance. When specifying a replacement transformer, consider the following factors. Firstly, the transformer's kVA rating. The transformer must be sized to handle the load demand. Secondly, the transformer's voltage rating. The transformer must be rated for the system voltage. Thirdly, the transformer's K-factor rating. The transformer must be rated for the expected level of harmonic distortion. Fourthly, the transformer's impedance. The transformer's impedance affects the fault current levels in the system. Fifthly, the transformer's cooling method. The transformer can be cooled by air or liquid. In addition, remember that harmonic distortion can also cause problems with other equipment in the electrical system, such as motors, generators, and electronic devices. Taking steps to reduce harmonic distortion can improve the reliability and efficiency of the entire electrical system. Also, ensure compliance with applicable standards and regulations related to harmonic distortion. Standards such as IEEE 519 provide guidance on acceptable levels of harmonic distortion. Furthermore, investigate the grounding system. An inadequate grounding system can exacerbate harmonic problems. Verify that the grounding system is properly designed and maintained. Moreover, consider using shielded cables. Shielded cables can reduce the amount of electromagnetic interference caused by harmonic current. Finally, implement a regular maintenance program for the transformer and other equipment. Regular maintenance can help identify and correct problems before they lead to more serious issues. Remember that addressing a high K-factor requires a systematic approach that involves verifying test parameters assessing load characteristics, considering harmonic filters and capacitors, monitoring transformer temperature, reducing transformer loading, evaluating transformer replacement, and consulting with a transformer specialist. It's also important to consider the additional factors previously mentioned, such as grounding, shielding, and maintenance. In summary, addressing a high K factor in a dry-type transformer requires a comprehensive approach, starting with accurate measurements and load assessment, exploring mitigation techniques like harmonic filters and K-factor correction capacitors, and then considering transformer replacement if necessary, are all important steps. Consulting with a specialist ensures the best solution for the specific situation. The goal is to maintain a stable and efficient electrical system while protecting the transformer from potential damage due to excessive harmonic distortion. The issue of harmonic distortion and K-factor is a complex one, and it's essential to address it properly to maintain the health and reliability of the electrical system.